Well, hey there, folks. It's Mr. Pilcher. I'm trapped at home right now, filming this from my spare bedroom. So crazy. So I'll miss you guys. I'll be gone for a little while, unfortunately, but hopefully I'll be back sooner than later. So here's the deal. We are going to continue Unit 6 today. We're going to do a little bit of review of what we already covered right before winter break, and then we're going to learn some new stuff today concerning polyatomic ions and compounds. So what we're going to do is we're going to do a brief review. We're going to learn some new stuff, and then you're going to do lots of practice. Now tomorrow, Miss Pepperly, the sub from yesterday, will be back. She taught chemistry here at Norris for many, many years, so she knows what she's doing. She's going to help you guys do some more practice over the polyatomic stuff that you guys learned today in class. And then the second half of class tomorrow, you guys are going to end up taking a quiz over polyatomic naming and compounds. So you would normally be taking this quiz today. I mentioned that in class on Tuesday, so I pushed it back a day so you guys can have a little bit extra time to practice. And don't worry, you'll have lots of time to practice in class today and in class tomorrow before you're taking that quiz. But without further ado, let's go ahead and get these notes officially started. Okay, so at the top here, I have a handful of examples of compounds and names. Now, these first three right here, let me go ahead and highlight these guys. They should look familiar. So this calcium fluoride, the sodium nitride, and the barium chloride. You guys, before you walked in today, should have been able to provide these formulas or provide these names if you were missing one or the other. Now, I know you guys are kind of rusty from break, so that's okay if this didn't go perfectly for you, but these are three that we can refer to as binary compounds. Okay, so these three guys are binary. What does that mean, Mr. Pilcher? Well, if you think about what a bicycle is, that is something that has two cycles, two wheels. So binary compounds are compounds that only have two different elements total. So that first one, you have just calcium and fluorine. Two elements total, and that's that. So binary compounds, they have their own naming system. But the moment you start to get three elements in a compound, so for example, you have potassium, carbon, and nitrogen right here, then you're going to start getting special names, and that's when that blue sheet comes into play. So notice this guy's called potassium cyanide, which you're like, what? Where did that name come from? The blue sheet will explain all, okay? So what we're going to do is we're going to compare the rules for binary and polyatomic compounds as we go through these notes so you can kind of see how things are the same for both and how things are different. And it's also going to be a way to help you review for the binary stuff. Okay, so for binary compounds, this is the stuff that we learned before break. You have a metal and a non-metal typically. So an element from the left side of the periodic table and an element from the right side of the periodic table. Now with polyatomic, you have many atoms that act as one ion off of the polyatomic ion sheet. Okay, so let's break this down a little bit. So if you guys learned in like a social studies class, someone who was polytheistic, that means multiple gods. So the word poly means multiple, and obviously atomic is referring to atoms. So these are when you have multiple atoms acting as one ion. And that's where this sheet comes into play right here. So this is that blue sheet you guys have. Okay. I hole punch this guy. You should keep this at the front of your binder. You're going to need it constantly. I would probably just keep it right with your periodic table because you're going to want to bust those two out like every day when you get to class because you're going to need them all the time. So this sheet has a lot going on here. So there's all kinds of different ions. We're going to talk about these here in a minute. But you'll notice that all of these have more than one atom. They're all negative. So there's anions, remember, anions are negative on the right. And then you have cations on the left. Ammonium, don't forget to look here. Don't sleep on ammonium. We'll get back to this here in a minute. But I just want you guys to know that this is the sheet that you guys are going to be using constantly. And you need to keep it somewhere safe. I'd probably just keep it with your periodic table so you don't lose it. All right, anyways, let's go ahead and get back to these notes. So, all right. Now, if we want to name a binary compound, we always have the positive ion go first. And then with our anion, that non-metal that comes second, we just chop off the N and put an I ending. Okay, and that should sound kind of familiar to you. Now with polyatomic, here's what we do. The positive ion always goes first, and the negative one always goes second, so that hasn't changed. Okay, again, don't forget about NH4. But then you have to pay attention. There's one thing you really need to pay attention to the details. So you'll notice on the polyatomic ion sheet, if you look at nitrate, that's listed as NO3 with a charge of -1. Nitrite is listed as a charge of, or is listed as NO2 with a charge of -1. But nitride, what is that? Well, that is just regular old nitrogen that had the N chopped off with an IDE ending, and so that's actually that -3 coming off your periodic table. So nitride, again, that is just talking about regular old nitrogen here on your periodic table. It's going to have a charge of -3. So don't forget, you're going to want to make sure you have all these charges saved up on your periodic table. You haven't already written those. You want to make sure you get those from a friend, okay? Because you're going to be using that all the time. All the time. Okay, now if I can get back to these notes here. Okay, so let's do a little bit of practice. How do we do this? Okay, so this first one, here's what you need to do. When you want to figure out whether you're doing binary rules or the polyatomic rules, here's the very first question you should ask. Does this compound have 2 elements only or more than 2? The moment you realize it has more than 2, you know you need that blue sheet, that polyatomic ion sheet. Okay, so for this first one, I'm looking at it. CaCO3. Well, I see the element calcium, I see the element carbon, and I see the element oxygen. Okay, boom. So the moment I realize I have more than 2 elements, I know I need my polyatomic ion sheet, my blue sheet. So here's how we go about naming this. We just write the positive name first. So Ca stands for the element calcium. So all we have to do to start this is just simply write out the word calcium. Okay. Now CO3, what's that called? Don't be tempted to be like, okay, it's like carbon oxide or something. No. So the moment you realize you have more than 2 elements, you need to go to the polyatomic ion sheet. But things are easy from there because you just write down whatever it says. So I'm just going to find CO3 over here on my little ion sheet. It is right here. If I can get my mouse over there, there we go. Boom. Has a charge of -2, and it's called carbonate. It's called carbonate. I just come back here, and all I have to do is just write out the word carbonate, exactly how it's spelled on that blue sheet. And so CaCO3 is called calcium carbonate. All right, let's try another one. So then now we have NH4OH. Okay, so I see N's, I see H's, I see O's up. Okay, so I got more than 2 elements. That means I definitely need my blue sheet again. All right, so I guess this is going to start with called nitrogen. And you're like, wait a second, hold on. Nitrogen, if you look at your periodic table, that's always going to be negative. So you're like, wait, that doesn't make sense. I shouldn't start with something negative. And so then this is that tip I gave you guys earlier. This is actually talking about that one positive polyatomic ion, NH4, right here on the left, top left-hand corner. Don't sleep on ammonium, okay? NH4. And as you guys get some practice here, you'll sort of have this reflex where you're like, oh, wait, NH4, oh, yeah, that's ammonium. And you'll kind of avoid that pitfall of being like, oh, that's nitrogen something? Like, no. NH4 is called ammonium. It's got a charge of +1. So, all right. So I'm coming back here. I'm just going to start by writing that name. Okay, ammonium, just like that. There we go. Okay, and then OH. What does OH stand for? Feel like the Buckeyes? Pretty good joke, right, guys? So you're just coming over here. You're just going to find OH. It is about halfway down here on the right-hand side. Here it is. You got some OH. It's called hydroxide. Got a charge of -1. So I'm just coming over here. This should be called ammonium hydroxide. Okay, now let's do one more here because we want to make sure we don't forget what we've already learned. All right, so this next one, MgBr2. How many different elements? Well, it has Mg and it has Br, and oh, that's it. Okay, so that means I don't need the blue sheet at all. This is just business as usual, binary compounds, stuff that we learned before winter break. Like, okay, all right, not a big deal. So I'm just going to go ahead and call this magnesium, because that's what Mg is. And then instead of bromine, this is just going to be called bromide. And that's that, okay? So later on, I'm going to go ahead and move on from this section, but later on you guys could try these remaining problems here. Again, hey, look, you got NH4 down there in the bottom right. Don't sleep on ammonium. But this is a two-way street, so we just went from the formulas to the names, but you also have to be able to go from the names to the formulas, which is a little bit trickier. It's a little bit trickier. Okay, so again, we're going to compare how we do this in binary versus polyatomic, see what's the same and what's different. Okay, with binary, when compounds only have two different elements, you label the charge of the ions first. So you have to figure out, hey, this guy's a +2, this one's a -1, or whatever. You have to do that first. The charge must always be neutral at the end, so everything has to add up to 0. All your positives have to cancel out all of your negatives. And then what happens is, if you need more than one element, you use a subscript, okay? So remember, a subscript is a tiny little number you write after the element symbol to indicate you have more than one of them. So if you needed a couple of oxygens in a problem, okay, wow, that is a suspect O, but whatever. You would go ahead and write a 2, a little 2 after it. It needs to be little. Okay, don't write a large 2. That'll get you into trouble in Unit 7. You write a little 2 right after it to indicate, hey, I need a couple of those oxygens to make this work. Now, with polyatomic, what you need to do is you need to label the charge of the ions. Okay, so the exact same first step. The charge must always be neutral. Exact same second step, so everything is the same for binary and polyatomic. And then what's going to happen, though, is if you ever need more than one polyatomic ion, you'll see why this is in a minute, you need to use parentheses and then that same subscript. So you need to use parentheses and then that same subscript. So, for example, okay, let's say I needed more than one of these OHs, hydroxides, that one we just used on the previous page, okay? So, let's say I need more than one of these. Say I need a couple of them. Now, if I don't use parentheses and I just put a 2 right here, this is just saying 1 oxygen and 2 hydrogens, okay? So, like, well, that's not what I mean. I need 2 of this whole thing. So what you need to do is, with the polyatomic ion, you need to put parentheses around it like this. So be like, hey, I need 2 of that whole thing. So this is now saying 2 hydroxides, 2 total O's, 2 total H's. Instead of what originally it said right here, this is just 1 O and 2 H's. But now with those parentheses, you have 2 O's and 2 H's. So we're going to do several practice problems involving this, okay? I'm move my slide here. Again, use parentheses if you have more than one. A lot of people like to write this right here on their blue sheet just to remind themselves, okay? So let's go ahead. Let's do a few of these problems here. Okay, so let's say we had the ions of B and Cn, okay? We're going to figure out how this would look visually. Then we're going to write the chemical formula, and lastly, we're going to name it, okay? So the very first thing we got to do is we have to find the charges of these guys. Well, B, that's just a single element on the periodic table. So you're going to go to your periodic table, you're going to find B, okay? It is in that third group. Circle it right here. Here's boron. So that means it's going to have a charge of +3 when it's being used in an ionic compound, okay? So boron's got a charge of +3. I'm going to go ahead and write that above it just to sort of remind myself. Okay. Now Cn, okay, that's more than one element. Okay, so that means it's a polyatomic ion, a multiple atom ion. So I'm going to use my blue sheet for that. So where is Cn? I scroll down a little bit. I find it here. It's called cyanide. If I can get a little highlighter here or underline it. Here it is right here. It's called cyanide. And notice anything that is on this sheet you never have to memorize. So you never have to memorize the name cyanide. You never have to memorize that formula Cn. And you don't have to memorize that the charge is -1. All of those will always be provided to you on any quiz or test. You never have to memorize anything on this sheet, okay, including tomorrow's quiz. Okay, so Cn is cyanide, and it's got a charge of -1. So the first thing I got to write down is sort of that charge. Now, visually, let's go ahead and plot this out. I'm going to write one of each. So I have a Bn +3, and then I put a Cn -1. Okay, now does that add up to 0 yet? No, it does not. Who do I need more of? Well, currently I have +3 -1. That gives me a total of +2. Well, that's not 0. It's a little too positive, so I need some more negative. So then I go ahead and I add another cyanide. And I'm doing a seesaw effect, and you guys can see where this is going. Like, okay, that's still too positive. I add another cyanide. Okay, now that's finally going to add up to 0. Great. Now I'm good to go. So it looks like I need 3 cyanides to go with the 1 boron. So here's our formula. Here's what people are going to be tempted to do. They're like, okay, got my boron, because I'm putting my positive one first. And then they're going to put a C, N, and they're like, okay, now Mr. Pilcher, I know I need 3 of these guys. My mouse is giving me a little bit of trouble there. There we go. So I know I need 3 of these guys, so they put a little 3 right here at the ends. There's one issue with this. This is saying 1 boron, 1 carbon, and 3 nitrogen. 3 nitrogen, okay? That is not what you mean. You mean 3 cyanides. So 3 total carbons and 3 total nitrogen. So here's what you need to do. You need to use those parentheses, ultimately giving you this formula right here. BCN3, just like this, okay? Now, what do we call this? Well, we just write the positive ion's name like normal. So that's just boron, okay? And then we just write, if it's a polyatomic ion sheet, we don't have to worry about chopping out the end and doing all that. We just write exactly what the polyatomic ion sheet, that blue sheet, says. So it says CN is called cyanide, so that's exactly what we're going to write, cyanide. And call it a day there. All right, now let's try maybe 1 or 2 more of these guys. Okay, so then we got NH4. First thing we got to do is we got to go to our polyatomic ion sheet. And you're going to notice we're actually going to have to find CO3 on there as well, because that's also multiple atoms, polyatomic multiple atoms, so it should be on the polyatomic ion sheet, the blue sheet. So let's find NH4 and CO3. Let's find their names and their charges here. So if I go over to my sheet, okay. Well, ammonium is up the top, NH4. Never forget, don't sleep on ammonium, top left-hand corner. And then CO3 is carbonate. We actually kind of talked about that one earlier in the notes. Ammonium's got a charge of +1, and carbonate's got a charge of -2. So if I'm coming back here, okay, +1, -2. Now with my visual representation, I'm just going to draw 1 of each to start off. Notice I'm putting my charges when I'm actually drawing these guys, and put my charges in that top right-hand corner of my compounds here, my ions, I should say. And CO3 -2. Now, this does not add up to 0 yet. +1 -2 is negative. It's a little too negative, so I need some more positive. I need another ammonium in the mix here. Boom. Now it adds up to 0. Everybody's happy. So when I come over here, again, people are going to be tempted to write something goofy like this. So they're like, okay. So they're like NH4, something like this. Oh, man. My handwriting is not good to begin with, but now it's really suspect when I'm writing with a mouse. Goodness. Okay, and I'm like, okay, so I need 2 of those. Boom, so they put a 2. I'm like, NH42! Be like, okay, you don't mean 42 hydrogens, okay? You mean 2 of the NH4 compounds, or ions, I should say. So you need to put parentheses around that NH4 when you need more than 1 of it. Okay, put a little 2 there. And then your CO3, okay, just like that. Now, what are we going to call this guy? Well, whenever you use anything from the blue sheet, the polyatomic ion sheet, you just write the name exactly as it appears on that blue sheet. Since both of these are from that blue sheet, you don't need to do any editing, any chopping off the end and putting an ion or anything like that. Just write exactly what it says. That sheet tells you that NH4 is called ammonium, and it tells you that CO3 is called carbonate. All right, now let's do 1 more here as a class. You'll notice that, hey, look, I have just 2 total elements here. Guess what? You don't need that blue sheet at all for this problem. You just go to your periodic table. You'll find sodium, element number 11. It's at group 1. Okay, it's going to be on the far left. It's got that +1 charge. So here's your sodium right here. I can circle that. Okay, it's got that +1 charge because it's in this first column. And then oxygen is way over here. It's going to have that -2 charge because it's in that 6th column. And to get its 8 valence electrons, it could lose 6 and become +6, but it's easier to just gain 2 and become -2. So anyway, so if I'm coming over here, I got the charges now. I got sodium as a +1, oxygen's a -2. So I'm going to go ahead and write out or draw one of each. Got the charges in the top right-hand corner of each of my ions. Like, oh, okay, that doesn't add up to 0 yet. I need a little bit more positive. Okay, so now it adds up to 0. We're gravy, good to go. So I need 2 sodiums to go with that 1 oxygen. And notice I don't need parentheses when it's a binary compound, okay, because the parentheses won't give me anything new in terms of information. So if I put parentheses around here, okay, the sodium, that doesn't tell me anything new. I still have 2 sodiums whether I put those parentheses there or not. So it is incorrect if you put parentheses when you don't need them. You should only use parentheses when you have more than 1 polyatomic ion. That is when you have more than 1 of an ion from that blue sheet, okay? So don't use parentheses when you don't need them. That actually would be incorrect, okay, come quiz time or test time. Only use them when you need to. Now, because this is binary, that tells me that I need to use those binary rules, so I'm just going to write the positive ion's name first. So I'm just going to go ahead and write sodium, business as usual. But then that oxygen becomes oxide, just like that, okay? So that oxygen becomes oxide instead of oxygen. So there's a few more practice problems on here you guys could do. Now, remember, the hardest part is going from the names to the formula. So just remember, you should always find the charges of each ion before you try and go from the names to the formula. That's really important. So what you guys can do now is the sub can hand you guys your worksheets. Here we go. Naming polyatomic ionic compounds, worksheet number 2. You guys, you can answer that first question too if you want to. But this is just going to be great practice for you guys. The answer key should be around the room now as well. So remember, do a couple problems, check a couple. And so I would work on this the rest of the period. Feel free to work with the partner as long as you guys aren't too loud or anything like that. And please let me know if you have any questions. So tomorrow what's going to happen is you guys are going to come in, you're going to do lots of practice with Miss Pep, who again taught this for many, many years before I was even born. She's really, really experienced, she's really good. So she can totally help you, she can answer any questions that you have, and then you'll take a quiz over this stuff towards the end of the period, okay? So that is a wrap for today. Again, just be careful with this last section where it has, okay, names going to formulas. That's pretty tough for folks. You always want to find the charges of everybody involved first. So in this problem, calcium would be a +2, and that's coming from your periodic table. That's just a regular old element. And then sulfate would just be that -2. And you'll realize, like, hey, wait, that's not a regular old element. That's coming from somewhere else. That is going to be on your blue polyatomic ion sheet. But once you realize the charges of these guys, you just have to make sure they're neutral when it's all said and done. So just be careful with that. Let's actually do a couple problems of that real quick. I just want to make sure we're feeling pretty good. So, all right, calcium sulfate. Well, those two just add up already as it is. So we're just going to go ahead and write a calcium here. They add up to 0, so we don't need to do anything fancy with subscripts or anything like that. And then sulfate, just coming from your polyatomic ion sheet, that's SO4. So I'm going to go ahead and write SO4, just like this. What about right here? Okay, so what about sodium sulfite? Sodium sulfite. Well, let's see. Well, sodium, coming from your periodic table, it's element number 11. We actually talked about that with the recent problem. That is a +1 in group 1 in your periodic table. And sulfite, be careful. This is not sulfide with an IDE ending, which is this guy over here. Okay, it's phyte, I-T-E. So we need to find sulfite that ends in an I-T-E. So if I'm coming over here to this sheet, if I can scroll down here, sulfite will be towards the bottom right-hand side of your blue sheet, and it has a formula of SO3 and a charge of -2. So, all right, so if I go back down here, I got that charge of -2 coming off of my blue sheet. There we go. Now, I need more than one sodium to make this neutral, so I'm going to go ahead and write my Na. There we go. Man, writing with the mouse, not my favorite. So I need 2 of those guys. And then sulfite, that is just your SO3. Again, don't confuse this with sulfide with an IDE ending, D as in dog, or sulfate, ATE ending, which is SO4. Boom, there you go. And how about we do one more of these that's going to be a little bit trickier. Let me see here. Which one of these guys is going to be a little goofy? How about, let's do magnesium bromate. Let's do magnesium bromate, the one a couple days. Okay, so if I go ahead and find magnesium, that's element number 12 on my periodic table. It's in group 2. You're going to see that it has a +2 charge to it. And bromate, again, that's on your blue sheet, your polyatomic ion sheet. We're coming over here. Here's your bromate. It's got a formula of BrO3 and it has a charge of -2. Charge of -2. So I'm scrolling down here. There we go. So it's got that. I'm sorry, not a charge of -2. It's got a charge of -1. I don't know why I said -2. Let me double check that. -1, right? Mr. Pilcher, yes, I've gone crazy. Okay, it's got a charge of -1. All right, well, if I add up one of each of these, that does not get me to 0 initially, so I'm going to need more than one bromate in the mix. Need a little bit more negative. So I got my magnesium. I just need one of those, my Mg. And then when I put my bromate here, here we go, BrO3. Now the mistake you want to avoid, okay, is a lot of people are just going to want to put like, okay, then, so I need 2 of those, so they put 2. But remember, this says BrO32. You don't mean 32 oxygens. You just mean 2 of those bromates. So I'm going to go ahead and pull this guy over a little bit here, just like this. And we need to put parentheses around that whole thing. Here we go. Let me get that 3. Come over here, little fella. So we need to put parentheses around the whole polyatomic ion because we want to, of this whole thing, this whole bromate ion, BrO3. So I'm putting parentheses around that. Boom, there we go. Okay. So again, do a couple, check a couple. Don't get too dependent on that answer key, but you can use it every so often to just make sure you're on the right track. And please let me know if you have any questions. All right, folks, that's a wrap. I will see you next time.